All right, in this video, we're going to talk about the antiderivative. So, most generally, say you have a derivative that was given to you, such as f prime of x equals 2x. When you're thinking about the antiderivative, you're saying to yourself, you're going backwards. So, you're saying, what was the original function f of x? So, what is a function f of x which has the derivative of 2x? So, the most obvious example would be x squared. You can check your work doing the power rule. If you were to use the power rule here, you would bring the 2 down in front, you would subtract 1 from the exponent, and you would get 2x. So this function has the derivative of 2x, which means this function right here is the antiderivative of 2x going in the opposite direction. Now, something to remember when you take the derivative is that if there were a constant at the end, so say you had x squared plus 7, this function would also have the derivative of 2x. Because when you have a k, when you add a number at the end, when you add a constant, it doesn't affect the derivative. Therefore, this function is also an antiderivative of 2x. There's actually infinitely many functions that could have this derivative 2x with any constant that you add at the end or even subtract. Therefore, the general antiderivative of f prime of x, we would actually write as f of x equals x squared plus c, saying that any constant could be added to the end, and that would have a derivative of 2x. Therefore, we don't actually know for sure what the antiderivative is or exactly what the function was that we took the derivative of, but we know that it was x squared plus some constant. Now, c could be 0, in which case the answer would be x squared. C could be 7, 21, negative 15, the square root of 2. It could be anything. So there's infinitely many. We also could just start with a function. Say we have f of x equals 3x squared, and then just talk about the antiderivative of that function. And when we talk about it that way, we actually use the notation of a capital letter. So the antiderivative of 3x squared is x cubed, once again, because the derivative of x cubed would be 3x squared. And then, of course, we have to consider that there could have been any kind of constant here. Now, there couldn't have been another term, like there couldn't have been an x or an x squared, because then that would have shown up in the derivative. But since a constant disappears when we go to the derivative, we know we have to add in that plus c because any number could have been there. So there's just two different notations. You can start with a derivative and go back and find the function, or you can start with a function and then you can write the antiderivative as the capital F of x. Things get slightly more complicated when there are coefficients, but I'll leave that to you to figure out and explore.